There are 3 generations of blockchain technology, maybe even 4, and understanding them helps you to get a grip on how does blockchain work, where does it come from, where is it going to, what is the whole industry doing. And so today we want to take a look at that. Welcome to Alice and Bob, where we talk about Web3 and everything that has to do with crypto. And today I want to look at the 3 or 4 generations, depending on how you want to look at it. They started with Bitcoin in 2009, and they are going until today, when we suddenly see a focus on mainstream adoption and everything that is associated with that. So let's dive right in. First generation of blockchain, 2009. The question back then was, okay, we have the internet. Can we have electronic cash? The problem is you always have to rely on a server that says this transaction is true, this transaction is false. So whoever controls that server will control the electronic cash. This is, of course, not what we want to have. We want to have decentralized money that is not controlled or can be censored by one authority. So this is why we have Bitcoin now. And Bitcoin answered the question, can we have a decentralized ledger? Can we decentralize control from this one server to a range of different servers? And the canonical example of that is, of course, Bitcoin, but there's also other blockchains that have been emerging around that time and a little bit later, like Litecoin, Monero, Zcash. So they all were focused on transferring money, right? So simple transactions based on proof of work. And there was not really a focus on programmability. We were basically happy that we could solve the basic problem of a decentralized network and agreeing on a common truth, on one source of truth, but in a decentralized manner. So the focus was on censorship resistance, resilience, decentralization, trustlessness. So those core attributes that we still talk about today. But of course, there were limitations. So a Bitcoin block comes in every 10 minutes. It has a limited amount of transactions that can go in. And so these were already very early discussion points. And then, of course, you cannot do a lot of logic and programmability in Bitcoin. And so this is where actually in 2014, the next generation, second generation of blockchain technology came along, and it answered the question, can we have full programmability? So it defined a virtual machine on top of the decentralized ledger. So you have data and you have logic. We're putting these things together and we're getting programmability. And so this is where we get Ethereum. I would say Cardano might also fall into this category. And what we have unlocked with this category is we have tokenization, we have smart contracts, so agreements. We can agree on certain things. Different users can agree in a way where it's solved by a computer that is on the web and is not controlled by a single entity. And it also unlocked and paved the way for DeFi and the in general, all the decentralized applications that we're using today. Also the composability. So the key question that still remained at that point in time is, okay, we have a computer, we can put any kind of program on it. So what if people start using it? Because we still have not solved throughput, we still have not solved the latency, etc., etc. So the questions then shifted on, okay, how can we solve scalability? And once we have all of these different blockchains, how do we solve interoperability? Because all of those blockchains, they live in their own separate universe. They have their own source of truth. But how can they actually talk to each other? And so starting from 2016, 17 on, we had this third generation of blockchains coming on, and they all had a focus on scalability, interoperability. So Solana, of course, is very popular or known for being very scalable. Polkadot, the parachain model, Cosmos, independent chains in a federated model, and Avalanche, sort of a mix with subnets, right? So different approaches to the same basic question of how can we have scalability and interoperability. There's also when bridges came along. So we had, for example, one solution in Ethereum was layer 2s, roll-ups, the modular design, multi-chain architectures, different consensus models that allow you to have more throughput, and also starting to focus on optimizing the execution layer, focusing on maybe introducing WASM, introducing RISC-V nowadays. optimistic rollups. Zero knowledge became a thing with ZK rollups. Data availability became a discussion. How much data can you put through? Can you put some of the execution off-chain, and how do you combine on-chain and off-chain execution? And how do you view topics and themes like settlement? And so this is where we spent most of the time in the last 7, 8, 9 years. And so in general, you could say that we are mostly focused on these things, the crypto industry as a whole, but there is an emerging fourth generation. So once you have those problems solved and you can see how those different systems are actually approaching solutions where there is enough scalability, throughput, etc., that you can actually stop considering them as a problem. So then the next challenge that emerges, which has been lingering all along, is can we actually create something useful on top of that? So there has always been a focus to create products, but now that all of these basic scalability problems are solved, there is nothing really to invest in terms of creating new bridges or scalability once, because we already have those systems. So a new challenger cannot just compete on those things. And so we're actually seeing the focus shift now to actual products being developed. So this can be business integrations. We see that the whole machine economy, deep in IoT integrations. We see that there is more focus going into user experience and actually focusing on actually creating something that is not for the tech affine people, but also for the regular user, similar to how Web 2 was maturing, and we basically got applications for the regular mainstream adoption. And in some extent, also there is questions about compliance and regulatory fit influencing the technology decisions. So not really sure if we can call this the fourth generation, because it seems a little bit different, but yeah, that's always the case when you have an emerging thing. And maybe another thing that is also interesting is also this focus on real time, like getting really to sub-second blocks, or like a few hundred milliseconds, or maybe even below 100 milliseconds. Everything always comes with a trade-off. So every time when you see someone make a big promise about how they, I don't know, have 1 trillion transactions per second and 10 millisecond block times, whatever, crypto and blockchain has a reason why it is slow, and that is because you want to have decentralization. You need everyone to agree on a common proof, so there's always trade-offs involved. But I think this short video should give you an understanding of why we have these different generations of blockchain technology. So I hope this is helpful for you. If you like the content, make sure to like and subscribe, and see you in the next video. Bye-bye.